NASA's instruments in orbit around the Moon have found evidence of water molecules bouncing around in the lunar orb's dayside, a groundbreaking Lunar Reconnaissance Orbiter (LRO) study has claimed. The incredible Moon discovery follows long-held assumptions the surface of the Moon is dry and inhospitable to liquid water. Up until the last decade or so, NASA said astronomers only expected water to exist in isolated pockets of ice near the Moon's poles. But a recent slew of discoveries, including NASA's latest find, have challenged the way scientists understand lunar hydration. Astronomers now believe small amounts of surface water are bound to the Moon's dusty gray soil or regolith. These small batches of water vary in amount and location and are dependent on the time of the day. But the discovery is exciting because it can help better plan future manned missions to the Moon, with the goal of setting up a permanent base of residence. Amanda Hendricks, the study's lead author, said, "These results aid in understanding the lunar water cycle and will ultimately help us learn about accessibility of water that can be used by humans in future missions to the Moon." Lunar water can potentially be used by humans to make fuel or to use for radiation shielding or thermal management, if these materials do not need to be launched from Earth. That makes these future missions more affordable. The lunar discovery has found water molecules are tightly bonded to the Moon's surface until around the time when temperatures peak at noon. The water molecules then thermally desorb and bounce around until they land in a location cold enough for the water to cool down and return to the surface. Dr. Kurt Rutherford, the principal investigator of the LRO's Lyman Alpha Mapping Project, LAMP, argued the discovery is particularly important now because NASA is returning to the Moon in the next decade. He said, "This is an important new result about lunar water, a hot topic as our nation's space program returns to a focus on lunar exploration. We recently converted the LAMP's light collection mode to measure reflected signals on the lunar dayside with more precision, allowing us to track more accurately where the water is and how much is present." And Dr. Michael Poston, a research scientist for LAMP, said, "Lunar hydration is tricky to measure from orbit, due to the complex way that light reflects off of the lunar surface. Previous research reported quantities of hopping water molecules that were too large to explain with known physical processes. I'm excited about these latest results because the amount of water interpreted here is consistent with what lab measurements indicate is possible." According to NASA, scientists have previously hypothesized ionized hydrogen carried on solar winds from the Sun could be the source of the Moon's water. This should result in the amount of water on the Moon decreasing, every time it passes behind the Earth and is shielded from the sunday. But this was not the case and, instead, NASA said water on the Moon builds up over time rather than raining down directly from the solar wind. John Keller, NASA's deputy project scientist for LRO, said, "This result is an important step in advancing the water story on the Moon and is a result of years of accumulated data from the LRO mission."